Hello, and welcome to Of Significance, the podcast about what's relevant, what's important, and what's meaningful. It's where we address whether the numbers and analytics we see daily are incredibly useful or nearly insignificant. I'm your every person host, Brent Buckwright, here with the man who samples more than a Costco shopper, Dr. Nathan Woods, and the Sultan of Statistics, Dr. Steve Bronars, experienced experts who have been analyzing big data since before it was big. Gentlemen, what's on tap?
Well, thank you so much for that introduction, Brent. Today, we thought we'd talk a little bit about correlation and causation, what they mean, similar, different. This one's motivated a little bit by a New York Times article I ran across recently, which is on a subject that's near and dear to me because one of my sons has been arguing with me for years, saying that sugar intake is not related to his level of activity. Saying there's no scientific evidence that your sugar intake has anything to do with how much activity, your hyperactivity, level of excitement, that sort of thing. And this article reminded me that he was right, and he'll be glad to know that he's right. That in fact there is no statistically established causal relationship between your level of sugar intake and your level of activity.
How did he know this? Did he have like a login account at JSTOR, or do you guys just get the American Medical Review coming to your house every week?
Yeah, we got to check the limits on the screen time, but I think he's got sort of unfettered access to a lot of information on the internet. But yeah, so in any event, he obviously was responding to me saying you shouldn't be drinking so much soda or eating so much cake or candy or whatever it is, and saying it actually doesn't have anything to do with what's going to happen as a result of that. And so, yeah, the article is pointing out that there's, this is a very common thing to kind of conflate something that is correlated with something that is causally related. In this case, you're excited because you're at the party, not because of the sugar that you're intaking while you're at the party. And somebody had tested this pretty thoroughly, and actually, as many different people have tested it over the years, using a randomized control trial where they give, the one group of randomly selected people the sugary foods, and another group of randomly selected folks the sweetened with aspartame, non-sugar, and there's no cognitive or behavioral differences as a result of the sugar intake.
And I think that that's really interesting to know, and it's important that they figure that out from randomized controlled trial, which we talked about before in the podcast, which is kind of the gold standard for estimating what the effect of a treatment might be. And so that's one way of trying to uncover a causal relationship. But I think as we talked about before, that's generally not the kind of information that we're going to have available to us. We're going to be working with what we call observational data, not experimental data. And what that is going to mean is that it's going to be more important to try to control for some of those other confounding factors if you don't have the ability to run experiments. Because what you're ultimately trying to do is still see whether there's evidence supporting this hypothesis that you would have that there is a causal relationship there. And while I think we consider the randomized control trial as like the gold standard, looking over the literature on this in terms of economics, Jim Heckman from University of Chicago, Nobel Prize winner, has made the case that these are really kind of black box models, the randomized control trials. You see what the treatment effect is on the people who were treated. And it may turn out to give you some very reliable information, but it could be the case that the effect of the treatment, in this case, I guess it would be sugar, could be different for different kids. For some, it might have a smaller effect. Some would have a larger effect. And so in that case, it's really hard to, extrapolate from your sample to a larger population what it is that you've learned, unless it's really much more of a homogeneous, in this case, I guess, absence of an effect. But if you did find an effect of something, how big is the effect? Which of the subjects, which of the people involved in the experiment had a bigger effect, smaller effect, and what can you learn from that? And what Heckman would argue is that you can't really learn that much. And so even though there's a real good thing about running experiments, there's also very limited information because it is kind of like you don't know why you're getting the result that you are. And I think in economics, we start more with a model and then we go from there.
And so you mean in terms of I've identified that effect, and then when I'm going to generalize it out to the population, I don't really know if I'm going to get that effect evenly across everybody, or if it's going to be subsets of the population that might experience more of the effect or less of the effect.
Right. If from the results of your experiment, you found that the size of the treatment effect was about the same across the experimental subjects, regardless of their age, gender, then it might be reasonable to think that even outside of that sample, when you're generalizing to the population, you would expect to see the same effect everywhere. But the experiment might not turn out that way. It might work for some patients and not for others, work more for some than it does for others. And then you'd have to study, like, well, what am I getting here and how could I use that information to extrapolate out to a larger group? So even though experiments are very helpful, they too will have some of their limitations. But the data that we deal with has even more issues than just that.
Right. So if I'm a human being who wants to understand if there's a causal relationship in something, I don't get to run randomized trials over anything, right? I mean, theoretically, I could set up an experiment to do one specific randomized trial on does sugar affect children's hyperactivity. But if I'm trying to look at some larger trend within an organization, or I'm trying to see if a policy has an effect difference, is there any ability for me to make those causal links in a meaningful way? Or am I always limited because it's not randomized?
I mean, you're always going to be somewhat limited. Doesn't mean that you can't, glean helpful information. I think what we're trying to do, and Steve mentioned the gold standard, and then mentioned maybe it's not so much a gold standard because it's this black box. But in general, I think what we're trying to do is to say, can we rule out all of the other alternative explanations than the one that we think is actually driving this thing? And so the way we try to do that a little bit is, using these kind of quasi-experimental designs and this observational data, but we're going to try to control for any of the other confounding factors, which might be age or gender or some other important factor that might explain the thing that we're measuring. So I don't know that you ever get to feeling 100% confident that you've identified a causal mechanism. I think the way I was brought up in my statistics classes, it was more the idea that, well, you're never going to quite get to causality, but what you can do is you can rule out these other alternative explanations, and you can say there's clearly an association as I hypothesized.
Or you could find that the controls that you put in, these, confounding factors, they accounted for the difference that you were seeing. And so you were left with really no effect of whatever the policy change was. And that would provide you some evidence that there wasn't a causal relationship there. But I think you're right. If you have limited availability of controlling for all these other factors, and you still see there's a relationship and you haven't been able to run experiments, then it could be that there is a causal relationship, or could be omitted variables that you don't have the ability to control for. And if you did, that's what's causing that's what's causing the correlation between this treatment and the outcome. And it's not really that the treatment caused the outcome. It's something else that's driving both of those. Your example of you're at the party, you're having fun, and that's where you're consuming the sugar for the kids. And I think the other thing
we could be having fun at a party too.
Yeah, we could be. I think the other thing in our modeling when we're doing this as consultants and experts is like, what I always think about is, where is the error term? Like, we're talking about basically, even though we're not saying this, running regressions. And the way the regression model looks, there's a relationship that's posited between some inputs and an output, and then there's an error term that's added to that. My question always, where is that error term coming from? And if we're talking about pay decisions in a company, we really don't think that there's a big random element to pay decisions, that the
Most
People
companies
running
don't have the spin the wheel and see what extra pay you get
Right.
at the end of the they don't have Price is Right rules on like,
exactly.
here's
It's
a
not
bonus
like,
for
you
you.
won the lottery today.
Yeah.
And we're going to pay you this. So it's taking the place of other factors really that we're unable to fully account for in the way in which we have modeled this process. And so that is another issue here. As Nathan is talking about, you want to try to rule out all the other possibilities given the information that you have and given the sample that you have.
Okay, so I want to bring up Spurious Correlations. It's a website by Tyler Vigen. Apologies if I mispronounce his name. Basically, what they do in the website is take two different sets of numbers and see if they're correlated over time to show that certain things might look like they've got some relationship. One of my favorites is the correlation between divorce rates in the United Kingdom and Disney movies being released. It ties pretty nicely together. It has an R squared of 0.85, which is, I think, pretty strong. But can you talk me through some of the narratives and the way that we think about our variables and whether or not they matter?
Before we go just a little bit further, for anybody who cares, the R squared, the highest it could get is 100%.
Yeah.
So 0.85 it's a pretty strong correlation.
Right. People miss those Disney movies, and it causes the top three reasons why people have
UK,
in the UK they have divorces is financial reasons, disagreements about politics, and then
too long since the latest Disney movie.
Yeah.
Yeah. So my reaction to that is, and we lose track of that a little bit sometimes in what we're doing because we're just analyzing data all day. But generally, we are starting with a theory of how the world works and trying to evaluate whether or not the data lines up with the hypotheses that you would generate given that theory. So if there was a theory that would connect those two things together, an economic theory that you could, test a hypothesis coming out of it, I would feel better about that. But since I don't think there is, I would say that's, it's a fun example, but it's silly. It's spurious, right?
Yeah. And I think that the other thing is that you go from this theory and then you say, okay, we're trying to do hypothesis testing when we're looking for this causal correlation. Is just, you have a lot of these funny examples on that website of things that just happen to be moving together. Usually would be over time. And so you have the theory, like Nathan said, and then you say, okay, how could we test this? What data could we have? Could we be able to isolate the impact? Since, again, we're approaching this, we don't get to run experiments. Can we, by putting together a data set, can we actually test to see whether this relationship hold or it doesn't hold? And that brings up this issue of what we call, in econometrics at least, identification. Is there a way to find a change in this policy variable, treatment variable, whatever we're going to call it, and the outcome that you're looking at? So if we're looking at something like pay differences, let's say between men and women in a job, we would need to have a job where there were both men and women in the job. If we were saying we're looking for pay differences within people doing the same job and the jobs were completely gender segregated, it's impossible to identify what the effect would be of gender on pay in that situation. You could look between jobs, but you wouldn't have the data to do that. So it doesn't even matter how large or small your sample is unless there is that independent variation in that factor that you're trying to look for the effect of. Then you can't even try to test that hypothesis and find out whether there is a gender difference. And then for something like that, the question is, well, is that causal, or is it due to some other omitted factors possibly?
So, some other counter argument, some other driver of the payout.
Right. Because whenever you're thinking about this, you have this hypothesis, and then you're thinking of what are the alternative explanations? What are the kind of other ways of possibly explaining whatever the finding is? Because if you were running an experiment, you could maybe rule out some of those others. But if you don't have the ability to do that, you're going to try to find as many ways to rule out other possible alternatives that could give you the same apparent outcome, but for a completely different causal reason.
Right. So as a practical example, suppose I was looking at pay differences between men and women in hourly positions, and I just kind of lump people together based on the same job, the same department, and I'd say, I see no difference there. You might say, well, hold on, there's something that you're not taking enough account of, which is something like tenure. And you look at tenure and you see that the average female is in this position for twice as long as the average male. So when they have these pay differences, the pay difference is actually just much larger, and you're missing a part of the story that goes into this like important relationship. Is that about right?
Yeah, to the extent that you think, and I believe we do, especially with an hourly population, that your tenure is going to be positively correlated with your pay outcome. If you don't have the hire date, you don't have tenure, you're leaving that out of the model. That's very likely to be a critical omitted variable. And then I think in the example that you've given, that's one that's kind of interesting. It's saying that I didn't see a difference. You've omitted the variable that if I took that into account, I might predict that women are actually going to they should be making even more because they're twice as they've been there twice as long. And so there really actually is a pay difference that you've identified once you took into account that omitted variable.
So when it comes to demonstrating correlation or getting to the level of causation, how do we do that practically in a economic consulting environment?
Well, I think that ultimately the way I would view it is in econometrics and economics, the goal is to try to make causal inferences. The goal is to try to understand how the world works and why things work in the way they do. It's just much more difficult to reach a definitive conclusion about that. Even when you find this relationship, you don't know that it's remain if we really were able to compare people, all other things held constant. You hold constant as many things as you can in the way that we model things, but we know that two individuals, we were talking about this pay example, that have exactly the same observed characteristics, they don't always get paid exactly the same thing. Okay, it could be two men, it could be two women, so we know it's not gender, but we don't understand because we don't have enough information in the data why one earns more than the other. So that's why I think while the goal would be to make these causal inferences, it's a pretty difficult standard to reach, because if you don't have all the proper controls that could be confounding this, then what looks to you like a causal relationship may really just be a correlation due to some omitted factor from the analysis.
Yeah, as a practical matter, we end up, all of our models are incomplete to some degree. We never have all of the factors that might theoretically be important to determining pay or whatever the other outcome we're looking at. So we do the best we can with the data that we have. We test out a lot of different models to make sure that we understand the impact of the different factors that we're putting in there, in addition to say...
You run your regressions more than once?
Yeah, it's true. Yeah, definitely. But I think from my own standpoint, once you kind of get to the point where you're trying to share those results with somebody, I'm going to share the results. I'm not probably ever going to use the word, I've identified this causal relationship, but I don't really have to, because what I really have identified is if there's some problematic result for one or another group, I'm saying you should go take a look at this group. It requires some attention, and I don't really have to say, and I think it's causally, my model has demonstrated that it's causally related. It's more just my model's demonstrated that you should go spend some time reviewing that group in that particular job.
Yeah, and I think that, Brent, the example that you gave, I have to go back on something I said earlier, where I said, well, if you don't find a relationship, then you might say there's an absence of a causal relationship. But even in that case, based on the example that you gave, if I added a new factor that I didn't have before, like length of time in the position, that could change the results. And so what I initially thought was no relationship between gender and pay, now all of a sudden there is one. So I think you need to be cautious whether you find that relationship that you haven't been able to explain with the other factors, or you don't. If you can't explain pay that well, there's still a lot of other factors out there, and you don't know if you had them how the model would look.
And clearly a takeaway is the better the model, the more thoughtful the model, the better the model is performing in terms of explaining variation in pay. You don't want to neglect important factors if you can help it. The closer you're going to get to feel good about whatever that result is, whether you're going to call it causality or but you're maybe not going to call it, I think this is just correlated. But I think for sure, if you don't have a very good model, or if you're leaving things out, you're going to feel much less comfortable saying anything about causality at all, even suggesting that you're close to it.
Well, that's been this episode of Significance. This episode's been brought to you by Edgeworth Economics, a leader in economic consulting, and with the help of our producers, Kimberly Krewald, Ryan Deal, and Brian McLamara of Brand Ready Media, with music by Armwell Lang. Thanks for listening, StatPack, and always remember to check your assumptions.